This video helps you get started in Python. It shows you how you use numbers, arithmetic operators, and expressions in Python, and it introduces the concepts of objects, types, names, and assignment. You'll work in PyCharm as you watch this video, so if you've not already done so, pause the video, open PyCharm, and then resume the video. In PyCharm, you'll probably see something like what's shown here in the video, where you've been working in the 01 Introduction to Python project. If instead you see something like this, just click on yourself there, and that'll bring you back into where you were. Since the last time that you worked in PyCharm, we've put the 02 project into your repository. So you need to update your repository to get that 02 project onto your own computer. You do so like this. You go off to VCS and then select Update Project, just like I'm doing there. Update Project. Pause the video and do that now if you have not already done so. You should now see the 02 project, like in my screen. Go ahead and minimize the 01. You might want to close all your windows up there to have a clean slate, and open up the 02 and its SRC to see the projects, the modules, and then open up M1E. I'm going to make my project information there be smaller. You don't have to do that because you've got more screen real estate. There are Moodle quizzes associated with this and all the remaining items in the left column, the column of videos reading. So go ahead and open up Moodle now. I'll tell you when it's time to do the first question. Once you have your screen adjusted so that you can see both this video and PyCharm, in particular the M1 module, M1 expressions of the Session 2 project, once you have those both visible, then go into the M1 expressions and do the first to do, which is to put your name there. So go ahead and do that and mark the to do as done. As always, just pause the video and rewind as necessary if you need extra time to catch up. There's a pair of import statements. They are not yet used but will be used in this project. To do 2 says that you do this module while you watch the Session 2 preparation video, the very one that you're watching right now. You do all the exercises in the module when the video says to do so. So we now mark to do 2 as done once you've absorbed that. And the video now says to go on to do 3, so you do so. Again, you go to the to-dos when the video says to do so, not before. So we're now in part 1 of our work in this video. It's on numbers, arithmetic, and what's called precedence. To do 3 says, again, doing it when the video says to do so, so that's now. You're going to uncomment the following and run the program paying close attention to what gets printed. Now to uncomment something, well, we've arranged so that when you run this thing, nothing shows up so far, which is what we want. But we also want that as you work through it, things start showing up. So we comment it out. We put hash marks or pound signs in front of these 5 lines of code. You can uncomment them to take away the hash signs by holding down the control key and pressing the slash that is directly below the question mark on your keyboard. Do so now. Hold down the control, select all 5 lines, hold down the control key, and press the slash that is undersigned the question mark. Doing it again puts them back into a comment. Try that several times, selecting the 5 lines, holding down the control key, and pressing the slash that is underneath the question mark. Once you have it so that they're uncommented there, it says to run them paying attention to what gets printed. So let's do that. So now we see some stuff. We see that we're working on to do 3. And it says that 4 plus 8 evaluates 2. So here's it being evaluated, and it's 12, of course. 7 times 10 is 70, and 1.53 plus 8 is 9.53. So the plus operator, the asterisk for multiplication work just like you'd think. Once you're comfortable with that, go ahead and mark to do 3 is done. Oh, it's not quite yet. it says to do an example of your own for division and subtraction. So pause the video now and then do an example of your own of division and subtraction and division. I'm going to show you what I'll do for subtraction just to get the idea across. I copied and pasted the previous one, and then I'm going to say 8.4 minus 3.2, and then I'm just going to put the same expression over here so that what I print and what gets evaluated is the same thing. And then I could run it and check that that really does evaluate to 5.2. So doing a similar, pause the video now if you haven't already, and do a similar expression, but with a couple of numbers doing division, using the symbol you would expect. I hope that you did something like the following, I'll just take the same one, and I'm just going to change my minus to division in both places. Again, I'm printing some strings, some words here, and then I'm also printing the result of dividing 8.4 by 3.2. So just a way to remind myself. So yeah, I believe that's 2.625. So mark this as done if you haven't already, and move on to do 4. To do 4 says to do this when the video says to do so, so we're about to do that. And it's asked that you uncomment those lines. Again, that's select them all, hold down the control key, and press the slash that is beneath the question mark. And then it says to run them. So there was to do 3 again, but here's to do 4. And this is showing you how that parentheses work exactly like you'd think they would. 4 plus 2, that expression is 6 times 3, that gives 18. 4 plus the expression 2 times 3, that's 4 plus 6, which is 10. If we put no parentheses, the order of precedence is that multiplication has a higher precedence, so it occurs before the plus. So this one is equivalent to the preceding one. I recommend that you always use parentheses to clarify, and then you don't have to sit there wondering whether plus or multiplication has higher precedence. Then here is subtraction going on, and just in case you're curious, amongst those with equal precedence, minus and plus, it goes left to right. So this is 4 minus 2, which gives 2, plus 3, which gives 5, as opposed to this one here, which is 4 minus the quantity, 2 plus 3. Once you feel like you've absorbed all that, mark that to do is done, and go on to do 5. Again, it says to uncomment some things and pay close attention to what gets printed. So I'm doing so, running it, and what I see is that 2 raised to the 10th power is 1,024. So double asterisk for what's called exponentiation, for raising to a power. 10 raised to the second power, 10 squared is 100, like you'd expect. 2 to the 0.5, so that's the square root of 2. There it is, as you'd expect. 10 to the minus 2 power, that's 1 over 10 squared, so we get 0.01. And then this one, that's 10 raised to the minus 0.5 power, means take 1/10, that's the minus, and then its square root, which happens to be about that. So make sure that you understand all those, and when you do, mark it as done and continue the video. If you fall behind at any point, just pause the video, rewind as needed, whatever. Here's to do 6. To do 6 is different. To do 6 says to type some expressions of your own that use combinations of addition, subtraction, multiplication, division, and exponentiation, using parentheses to make clear the order of operations. Then run the program to see that what gets printed is what you expect. So I will uncomment those. I'm going to do one as an example, but you should do a different one just to make sure you know what's going on. So I'm just going to print some expression. I'm going to take 4 plus 3 raised to the second power. So that's 7 squared. That should be about 49, I think. and then I'm going to divide that by 2, so that should give us 24.5. And that'll be enough for me. So I'm going to run that and check that I get, yes, 24.5. So again, type in some expression of your own, not the same one as I did. Run it and make sure you're good. Type in as much as you need to do until you're comfortable with addition, subtraction, multiplication, division, and exponentiation, with parentheses as needed. Once you're comfortable with all that, go off into the Moodle quiz and do part 1 of the Moodle quiz on this video. It's on numbers, arithmetic, and precedence. Just part 1. Do the questions in just part 1. Pause the video, do that quiz, and then come back here to the video. You should have now finished to-dos 1 through 6 of Module M1E expression, and also have done part 1 of the Moodle quiz on numbers, arithmetic, and precedence. If you have questions about that quiz, reach out to your instructors or an assistant for help. Let's continue now to to-do 7, which is the beginning of part 2 on a topic called exceptions, and in particular syntax and runtime errors. An exception is the word we use for when a Python program does something exceptional. For example, if it has some error that causes the program to crash. There are many kinds of exceptions. Here we'll investigate a couple of them. Python programs have a notation, that's what we call the syntax of the program, that is required for the Python interpreter to execute or run the program. Violations of the required notation are called syntax errors. Uncomment the expression here, as it says in to-do 7, and you'll see that this third line is highlighted in red by PyCharm as code that will produce a syntax error when it runs. It's just not legal notation in Python. It's not even close. Let's in fact, run it. And we see that it says it's a syntax error. It's invalid syntax, invalid notation. Go ahead and first comment out that line, and then add some short, silly thing that you think might include syntax errors. For example, you might put some expression that's missing a required parenthesis. Go ahead and do that now. Pause the video and do that now. I'll type one, but don't type the one that I'm doing. Just pause the video and do one yourself. Here's the one that I've done. I put a print statement, but made print in uppercase. Case matters in Python, so uppercase print and lowercase print are just different from each other. Here, when I ran, by the way, the error message appeared up high in the screen, even though other stuff, which executed first, appears lower. That can happen. What's called error output is put to the console, to this window, separately from what's called output, ordinary output, and sometimes it puts the error output before it gets around to doing the ordinary output. So whenever you think something might have crashed, look up higher and see if you see the error message there. So I hope you've done some error of your own. Comment out your error, and let's go on to to-do 8 after marking to-do 7 is done. For to-do 8, he says to uncomment the following, so I'll do so, and then run the program. And this points out explicitly that those error messages might appear up top. So here we're running it. Here the error message for me appeared lower, but it might have appeared up top there for you. Just depends on various things that are more or less random. This one prints to do 8, evaluates 3 plus 2 to 5, and then attempts to evaluate 3/0. Now this is not a syntax error because the notation is just fine. Rather, it's what's called a runtime error, a specific type of runtime error called a zero division error, where you divided by 0. So these messages here at the end of the error message are invaluable, and for many of them, if you just read the message, you'll see what it's trying to say, and then you can go back and fix the error. The blue part here shows where the code actually crashed. So I can click on that line and it takes me right to where the error occurred. So if I were for some reason down here, I clicked on the blue, it takes me right to the error that caused that error message. So that's your habit. When you see a crash, click on the blue, read the error message carefully, and then fix things as needed. Here, let's just comment out that line so we can continue and mark to do 8 as done. Moving ahead to do 9 says to comment out these ones and then run. And we see that there's to do 9. For me, the error message appeared up high again. This is an extraordinarily common message that you want to pay close attention to. Let's pull it all out. It says that this statement is a type error. It says an unsupported operand types for slash. So you look for the slash in that statement. That's the operand. And it says there's an int to the left of the slash and a string to the right of it. So if you see a message like this, unsupported operand types for blah, colon, blah, and blah, you should now be able to make sense of that message and fix your code accordingly. So I'm going to click on the blue there to go to the line that broke. And of course that is an error to try to divide 3 by a string. So I'll just comment it out so that we can continue on moving. Now I'll mark to do 9 is done. Continue on. As always, if you are uncertain about things, pause the program, do some experimenting of your own, and then move ahead. So this one says type some expressions of your own choosing that cause error message, then run the program paying attention to the last line of the error message in red. So go ahead and do that. While you're doing it, you should do your own ones, but while you're doing that, I'm going to do a couple just for funs, but you should make your own ones. Let's see. Let's try this. So again, you're doing your own one, but indenting matters. So there's an incorrect statement. We've only barely talked about range statements, more on them coming up soon, but you saw in the first video that that's the form of it. Whenever you have a for statement or a def that you'll see coming up in the next set of videos, you indent the stuff that's in the body that follows the colon till the end of that stuff. And in general, it can be several lines of code. So I'm going to run. Again, you can put whatever you want as an error message. Here's mine, unexpected indent. Well, that means I click on the blue, and there's an unexpected indent here. I'll mention that error messages are often on the line before the one that is flagged as an error. So I'm going to go ahead and comment that out so that I have one. I want to show you that this one works. There we go. And I want to do one more just for you to see. You don't have to put it in yours. To see that if I do something like this, where I have purposefully left off a missing parenthesis, sometimes it flags it up there, but sometimes it flags it on this line. So it just depends on various things as to whether it flags it on that line or at the beginning of this line. You'll get lots of practice on fixing errors in session 2. Alrighty, I'm going to just continue on, make sure that that still runs fine, and then I'll mark that to do is done and continue on. And what you should do at this point is that once you feel like you understand the basics of these syntax errors and more generally the exceptions that are called runtime errors, do part 2 of the Moodle quiz on exceptions, syntax, and runtime errors. So pause the video now and do part 2 of the Moodle quiz associated with this video. So I'm going to mark to do 11 is done, and to go down here to 12, where we're going to discuss the fact that the type of the object says things about what it can do. You can do with it. So for example, let's see. First it says it's to type an expression that involves addition, subtraction, and multiplication, but not division. So I'll uncomment the beginning here, and I'm going to type some expression, and then I'm going to try to find out what type it is. So you should do the same. You pick your own expression there, something that involves addition, subtraction, and multiplication, but not division, using whole numbers. So, I don't know, 9 plus 3, 3 times 4, minus 6. And then what I'm interested in is the type of that result. So I'll print that and run it, and it is an int. So if you do operations on integers other than division, you get an int. Then it says to repeat the above, but make just one of those numbers a float by appending a decimal point to it. So you should do your example, but you can just take your example. I'll put 9.0. So it's the same number, well, almost the same number, but it computes it, and it's now a floating point number. Arithmetic with floating point numbers is done slightly differently internally than whole numbers. Arithmetic in Python with whole numbers is done exactly, no matter how big the integers are. Arithmetic with floating point numbers, numbers with decimal points, are done with limited precision and limited magnitude, as is typical of other languages as well. We'll see more about that later. Once you've got the hang of that, then go ahead and uncomment these to see division. Let's do that and look together at the results. So we see when we do division that one float divided by another float gives a float. One float divided by an integer still gives us our float here. And a integer divided by an integer gives us a floating point number. So division always results in floating point numbers, even if the numbers are whole numbers, and even if the whole numbers yield a whole number, as in this example. So to summarize, there's both ints and floats. Ints are computed, arithmetic with ints is done exactly except for division. Arithmetic with floats has limited precision and magnitude. We'll learn more about that later. Mark to do 12 is done. Let's continue on to do 13. This one here introduces two new operators, a slash slash and a percent. The first one is called integer division. So 17 integer divided by 5 means you divide 5 into 17 and see how many whole times it goes into that. So 5 goes into 17 how many whole times? I hope you said 3 whole times. 5 goes into 17 3 whole times, getting 15 of the 17. And the remainder, the leftover, when you divide 5 into 17, is 2. Goes in 3 times for 15, and there's 2, 17 minus 15, left over. So double slash means divide 5 into 17 and see how many whole times it goes in, yielding an integer. 17% 5 means what's the remainder when you divide 5 into 17, and that is also an integer. Let's go ahead and run that. You should do the same. And as predicted, the 17 integer divided by 5 gives 3. 17 remainder when you divide by 5 is 2. Go ahead and type some more expressions with slash slash and and percent till you get the hang of that. I'll type a few right while you're doing it. So you do a few too, but I'll do a few more and talk through them even while you're typing. So you should be typing right as I'm talking. So let's print, I don't know. Let's see here. 39% 10. I think that'll go, 10 will go on to 39 3 whole times and a remainder of 9. And then so 39 double slash 10 should give us 3. Let's see if that's true. And yes, 9 and 3, remainder 9. I'll do one more example, but just do whatever you need so you're clear what percent and double slash do. 100 double slash 10 should go up 10 whole times. Let's do something else. Let's do 5, which will go 20 times. And 100% 5 should give us 0 because 5 goes into 120 whole times with no remainder. No remainder. If you have questions about what double slash or percent do, just ask your instructor or an assistant for help, either after the session or at the beginning of the next. Let's mark that as done, and we'll move ahead to number 14. Throughout this, if you have questions about any of these, just reach out to your instructor or an assistant or bring your questions to class. Let's see, this one says to uncomment the following, paying attention to what gets printed. So this one's going to show us how you can do arithmetic, C plus, with strings. What do you think would happen if you have hello plus goodbye girl or big times 20? Let's run and see. You should comment it out and run it yourself. And what we see here is that plus says hello, goodbye, hello, followed by goodbye girl. So plus means we use the fancy word concatenate, hello followed by or concatenated with goodbye girl. Big times 20 makes big show up 20 times. And here's an example that combines the two, hello space, goodbye space, 4 times. So now you know about string arithmetic. So you know both about arithmetic with numbers and arithmetic with strings. If the type of the thing is a string, plus is treated one way. If the type is a number, plus is treated in the ordinary numeric way. So that's what I mean by saying the type of the object determines what it can do, how things are treated with it. Let's see here. Strings are interesting in that you want to sometimes use things that contain perhaps both double quotes and single quotes. So you're to type a statement that prints I apostrophe M, so I'm not a bug, that's right, just like that. So take a moment, see if you can type some statement that will print that. It's very easy. Hint is, consider both double quotes and single quotes. I'll show you my answer, so if you're having troubles with yours, you can look at mine. But perhaps you figured out that it's print, and I can use double quote, so everything in here is a string, and then I can put single quotes in there. That's sort of why Python likes to do it this way, is that if you have mixed quotes and double quotes, you can use one on the outside and another on the inside. So there we go. That will print our desired result. I'm not a bug with apostrophes. That's right. So double quotes to make the whole thing inside here a string. Since it's a string, the characters are just characters, and the apostrophe doesn't mean that we're starting a string there. It just means an apostrophe. Single quote. Go ahead and do the following. Print the sentence, what does double quote, Yarborough double quote mean? Go ahead and do that now. The hint is just put it in the whole expression in single quotes. So now I'm using single quotes to say this stuff is a string, and the double quotes is printed as just characters of that string. There we go. Again, type in these yourself so that you have them in your notes and get some muscle memory. This one's tricky. I'm on pins and needles about quote, double quote, single quote, double quote, period. See what you can do with that. I think you'll find that if you use the plus operator as part of your solution, that might help. Just give you a few seconds to think about and type your own. Pause the video if you want to think some more. But I'll go ahead and show a solution. Again, you should attempt the solution first. Let's see. I'm going to start with a doubly quoted string because I want to do the single quote inside there. I'm on, and I go through the space, and then I use the plus operator to put another string right after it. I've just finished through the space after on. Now I'll switch off to single quotes, and I can put double quote, pins and needles, double quote, about, space, single quote. Nope, not single quote. I'll put now my single quote that finishes on that, so that goes through the space after the space after it goes through the space after the word about. Now I'm ready to do a single quote, so I'll put that inside double quotes. And then I'm supposed to do a double quote, so I'll put that inside single quotes. And then I'm supposed to do another single quote, so I'll put that inside double quotes. And then I'll append to that, concatenate to that, a double quote, so I'll put that inside single quotes. And then I think I'm supposed to end up with a period. Yes, so I can put that in there. Let's see if I got that right. I'm on, double quote, pins and needles, double quote, about, single double, period. Single double, period. So I hope you see how you can use mixed single quotes and double quotes if you ever need to use both in some thing that you're dealing with, printing or whatever. So after you feel that you understand the basics of what we just did in the preceding to-dos, do part 3 of the Moodle quiz. That is the part on objects, types, and values. So pause the video now and do part 3 of that quiz. You can always come back to this video, by the way, while you're answering those Moodle quizzes. They aren't exams, they're just ways to try to help you help you strengthen your understanding of the video. So by now you should have done to-dos 1 through 16 and parts 1, 2, and 3 of the Moodle quiz associated with this video. We now enter part 4, our last part, names, variables, and assignment. We use names to refer to objects. We often use the word variable instead of name, since the value of the object to which the name refers can vary over time. Here's an example of a diagram that shows the name greeting might refer to the object per the diagram below. This picture shows that the name greeting refers to a piece of storage in the computer whose type is string, str, and whose value is the letters HELLO space WORLD. Another name, or the same name, might refer to something that is of type int, as shown to the far left of this picture, or type float, or type list, which is shown to the far right. The value of a name is the object to which the name refers. So a name gets its value through assignment. One way to do assignment is by using the equal sign operators, and you should read it as gets operator. For example, to make greeting refer to the object above, we would write greeting gets equal sign, quote, hello world. Let's continue in PyCharm. We're again in part 4, names, variables, and assignment, and we're ready to do 16. It says to uncomment the following and then see what happens. So I'm going to uncomment the entire thing, select the whole set of lines, Control/, and you can see already that there's a problem here, that the name greeting has not been defined up here. Contrast that with first program, which has been given a value. So first program is the name, and its value is hello world. Greeting has no, at this point, no value. So when we run, we get an error message saying name error, greeting is not defined. So that should be a clear message to you from here on out, and you'll spot it almost always before you actually run the program because it'll be marked in red. Let's comment that out and run again so we can see what we've got next. And you see that what happens next is greeting is assigned a value, hello earthlings. It prints it, hello earthlings. And then it prints first program, whose value is still hello world, plus 2 of the greetings, hello world, and then 2 hello earthlings. Then sets another name, n, to 3, and prints first program, whose value is hello world, times n, whose value is 3. So this evaluates to hello world times 3, which evaluates to hello world, hello world, hello world. We can reassign variables, so or our names. N becomes twice first program now. So when we do n, which is twice hello world, hello world, hello world, plus the greeting, we should get hello world, and then hello earthlings. Make sure that you follow all that. Pause the video and replay it as needed. And then mark to do 16 is done, and move on to do 17. So do to do 17, as it says, uncomment the following and then run the program, paying attention to what gets printed, and it's a reminder that error output may appear up high even before the output from standard output, that even if the standard output follows the thing that caused the error message. So here we go. So we're going to run this, and we'll see that it gives an error message. 0 division error, division by 0. So we click on the blue to get to the line that failed. Let's see what happened. R was set to 0, S was set to refer to -9, and then T gets the value, or refers to, S minus 9 divided by R, whose value is 0. And that does indeed yield a division error. So the syntax is just fine, but at runtime, the program crashes. Let's comment out that, work right along beside me, and run again. Let's see what's going to happen this time. We're going to take oops plus S, oops plus -9. I hope you can believe that that's going to yield an error message. And this is one, again, you'll see lots and lots. So make sure you follow it. Type error can only concatenate, that means do the plus of strings, append a string, can only concatenate a string, not an int, to a string. Here's a string. You can attempt to concatenate only strings, not ints, as S is at that point in time. So be sure that you're following how to make sense of these error messages. You'll get better at them over time. Let's continue on. So we're going to comment out that failed line and repeat again. What's going to go wrong with this one? The square root of -2. It should give us some error message there. And here we are, value error, math domain error. So the domain of the square root can't include negatives. Again, just move right along with me, commenting them out one by one. This one is probably a surprise to you. It's going to take -2, just like we had, raised to the 0.5 power, which many people would say is taking the square root of it. But PyCharm does it a little differently here. You'll see when we run. PyCharm treats that as what's called complex arithmetic and gives what's called the value of it in the one plane, and the value in the I plane, and the value in the J plane. The value in the I plane, let's see how to read this. This is, see little e, 10 times this number to the -17th power. So that's almost 0. teeny number plus the square root of 2 in the j plane. Now, you probably don't know anything about complex numbers yet, but you'll learn about it in calculus soon enough. And so there we go. Just wanted to point that out to you. Nothing important. So let's mark to do 17 as done. Oh, let's see here. To do 17, yes, continue it. And then it says try out your own assignment statements that yield runtime errors. So go ahead and do some statement here that you think will yield a runtime error. You can choose whatever you want. Let's see. But an assignment statement, something that involves assignments. So, I don't know. X, you can do whatever you want, but I'm just going to try this one. X equal, what's an assignment that will not work? Hello divided by goodbye. So that certainly won't work. And so when we run, we get an error message, unsupported operand types for slash. We've seen that one before. That means you look at the slash, there it is, string to the left, string to the right. Can't have a string divided by a string. So you do whatever you want there just to get the hang of it, and then move ahead. Comment out your failing one, mark to do 17 is done, and then move on to do 18. To do 18 says to uncomment these and then try running it. So we'll do that. But first let's, here we are. This one points out that assignment is not symmetric. So when you say blah equals such and such, first the right-hand side is evaluated or computed, thus yielding an object, and then the name or variable on the left-hand side is made to refer to the object on the right-hand side. So this one evaluates 45. Well, it's not much to evaluate, but in general it would compute whatever's on the right-hand side of the assignment, and then it sets the name A to refer to that constructed object. Doing it this way makes no sense because 45 is not a name. So when we run this, we should get an error message. And we do syntax error because you can't put names on the left-hand side. So I'm going to comment that out, and then I'm going to run again. Let's see. A gets 45, B gets 10, C gets B, which is 10 plus 20, so C should be 30. B gets C, B will turn into 30. We should see 45, 30, 30. If you didn't follow where the 45, 30, 30 came from, rerun the video here or back over the last little bit. Then mark that as done and continue on to 19. 19 says uncomment these, but predict what will get printed. So take a moment. It's going to say to do 19. X gets 5. There's an interesting statement. Predict what X's value will turn into and get printed here. The statement here is very typical computer science, although horrible mathematics. And that's clear when you read this equal as a gets. X gets 5, X gets, and remember we calculate this part first, the old value of X, 5, plus 1. So we evaluate that, get 6, X gets 6, and we should have 6 printed. Take a moment to figure out what will get printed then, and then go ahead and run to see what the result is. And I hope you see that it's 6, 7, and 8. 6 from here, X gets 6 plus 1 becomes 7. X gets 7 plus 1 becomes 8. Again, if you didn't follow that, just rewind the video and look more closely at it, and definitely bring questions to your instructor or an assistant, either outside of class or at the beginning of your next session. Here's another one where you're just going to predict things. This one says X gets 10, Y gets 75. Now this is, PyCharm says this is an error, or at least a warning, because it's silly code, which it is. Let's see here. X gets 7, Y gets 75. Now you might think that X gets Y and Y gets X. We'll swap those two so that this would print, let's see, X, it would print 75, 10. That's not true. Pause for a moment and figure out what will get printed. It will not be 7510. And then after you've figured that out, or at least given it some thought, run the statement to see. Again, think through it here. Think through it. While you're thinking, I'll sort of speak through it. X gets Y. Compute the right-hand side, 75. X becomes 75. X is 75. Compute the right-hand side of this one, 75. Y gets 75. So this one should print 75, 75. And there it is. So this is not correct code to swap the value of two numbers. This next one gives you a chance to write your own swap. Let's mark that as done. And then continue on to 21. 21, and our last one here, says uncomment these. Now what this does, let's just look at these here, is it uses the random module. There was an import random way up top here. Import random. And then from the random module, it applies the randint method that returns a number between 1 and 99 inclusive. So it could be as little as 1 or as big as 99, and it's an integer. So 1, 2, 3, 4, whatever. And every time you run this, you get different random numbers. So I got 95 and 47 that time. This time I get 22 and 3, and so forth. Now we'll talk at a later point about how randomness is really done in a computer, but you can think of them as random numbers. So these statements make X and Y two more or less random numbers. What I'd like you to do is to think about what code you can put here that will swap the values of X and Y. So in this case, if X and Y were 58 and 42, your code should make it so that X is 42 and Y is 58. Swap them. I'll point out that the following we just saw didn't work. So you're going to need something different than this. As a hint, I'll tell you that you have to have a third statement. So, you'll test your code by printing them again and seeing whether after your code, so you're not going to do this, you're going to do something, well, sort of like that. It'll have to be 3 lines, not 2. You'll see what you can do. Take up to a minute to solve this puzzle of trying to figure out how you would swap. Pause the video now. Take up to a minute to try to figure out how to do swap. I hope that you gave that a minute's thought and tried out your answer. If you didn't, pause the video and give it a minute's thought and try out your answer. If you're not getting anywhere after a minute, then we'll resume this video. So I'm going to trust that you actually did give it some thought. Here's what the swapping pattern is. You start by storing X. You make temp refer to what X is. You can use any name you like, but temp is a popular choice because it's a temporary name, something that will be used only temporarily. So temp refers to what X refers to at this point. So we have 2 names for the same thing, temp and X. We can now destroy X and make that name refer to Y's current value. So at that point, we have temp referring to what X originally was, and X and Y both referring to Y's original value. Now we can destroy Y, sending it to temp, and then Y will be referring to what was originally X. X is referring to what is originally Y. So that's the swapping pattern. It sort of makes a little Z there, if you can sort of picture it as sort of a Z. Let's run it, check that that works. Let's see, they were originally 1 and 23, and they got swapped to 23 and 1. That concludes the pie chart part of this. You have one more thing to do. Go back to part 4 of the Moodle quiz on names, variables, and assignments, and do part 4 of that Moodle quiz. That will end this exercise and this video after you've done part 4 of the quiz. You learned a lot of details here. They'll all come naturally to you over the next several sessions, but start making notes to yourself about anything in here that you think you might have trouble remembering, and then have those notes ready as you code. Good work.